Third year, sir.
Oh, fine, fine. Okay, thank you for sharing your information. Any other would like to speak on?
Sir, am I audible?
Not
Am I audible, sir?
yes, yes, sir, you're audible.
Yes, sir, you're audible.
I was saying that astronomy without telescopes. So I believe it would be of time when we had no telescopes, so we have to do astronomy by seeing objects from our naked eyes. So I feel like after this webinar, I would be able to see the sky with a lot more detail and how it varies according to the seasons and all those things. So I would
Yes,
get a better
expect
detail.
that. Yeah, it's great to start with that, and I hope. Yes, I also don't know about what she's gonna be teach now. Yesterday I have asked the PPT also, but she didn't share me because of some, from due to some confidential data over there in the PPT. Right. Anyway, so if Kirti have came, I just want to introduce her. Let me see whether she came or not. Mm, no, she have not yet joined because she's trying to do some kind. Oh, yes, yes, she's joined. Fine, fine. Kirti, can we have a privilege to listen to voice?
Hello.
Hello, Kirti.
Yes, Sharon.
Yeah, fine, fine, Kirti. Right. Are you ready? Shall we proceed?
Yeah, sure.
Right. Okay, guys. So welcome to this webinar on astronomy before invention of the telescope. Right now, I just want to introduce Miss Kirti Tomar. So you know, she's something like a beyond our limitation. We have a lot of information to express about her. Well, fine. Let me introduce about her. Few in few lines. She's a citizen scientist at NASA. All of you know about very well about NASA, and she also working as a trainee astronomer and astrophotographer. The one who take the photograph of Milky Way and all the galaxies and whatnot regarding space. And she also a science communicator. She is also the participant of gravitational wave communication community, everything. And she's also the founder and CEO or MD of this futuristic photons. It is also a space education company, and this is all regarding her regarding the professional stuff. And she's also beyond that, she's also a writer, author for several books, and she's also appeared on several kind of digital platforms in multiple times, in couple of times also. And she's also written a book called Goonj. So I have also applied to I'm also getting that book soon. Right, so this is what a brief introduction about Kirti, and I expect this is the second webinar we got from Kirti Tomar, and it's a great honor for all of the organization members, and it's very beautiful to you. It's the greatest opportunity for all of you participants because you people may not get such an opportunities every time, and Igniter Minds is such an organization is trying to give you such offers, many of times. Recently on 28th of February, we have conducted the same webinar by our mentor Kirti itself, and this is after a long time. This is a uh, meeting about her with her. Fine. So thank you, Kirti, for giving me the privilege to introduce yourself, and I'm just handing over to Ms. Kirti Tomar. Please welcome everybody. So I just want to, if there is a possibility, turn on your mic and please welcome our guest, Ms. Kirti Tomar, the citizen scientist at NASA. Thank you. Handing over to you, Kirti. Guys, come on, let us invite
Thank you
her.
so
Open
much,
your mics.
Sharon.
A warm welcome, madam.
Good afternoon,
Thank
madam.
you, all of
Welcome,
you,
ma'am.
Afternoon, madam.
especially.
Good afternoon, madam.
Good afternoon, madam.
Good afternoon. Good afternoon. Thank you for this warm welcome, Charan. Okay, so yeah, this is my second webinar here, and let's see. Okay, so can we proceed? Hello, am I audible?
Yes, ma'am.
Yes,
Ma'am, you're audible.
Yes, ma'am.
Okay, so let me share my presentation. Wait. Is it visible?
Yes, ma'am.
Yes, ma'am.
Yes,
Okay,
ma'am.
okay. So, good afternoon, everyone. And today we are going to have a session on one of the most amazing topics of astronomy, that is astronomy before telescope. So, have you ever wondered how things were like before the invention of telescope? How people were able to see objects in the sky? How people find their directions? How did they tell the time by using stars? How do they find north direction, south? How do they know the eclipses, lunar eclipse, solar eclipses? How did they happen? Also, how do they know the dates of festival and how the year starts? How do they know observe the sky before the telescope? So these kind of questions, there are tons of questions, millions of questions, which still blows our mind, right? So let's start today's session about astronomy before telescope. Okay, so before the invention of telescope, long before this invention itself, the ancient people got to know about many things. All astronomical observations were made with the naked eyes. Our perceptions of the universe was limited by our own eyes. They used measuring instruments. Astronomers recorded the position of the planets against the background of stars. Even before the telescope was invented, like this is the star cluster Pleiades. If we talk about the real time sky, then there are 6 7 stars, the group of stars which we able to see with our own eyes in dark skies. So any of you have seen this before?
No, ma'am.
No, ma'am.
So try it out. Just look at the dark. If you are in the dark sky, so just look at the sky, and there is some constellations or group of stars, 6 to 7 stars. That is Pleiades, and the Pleiades is a star cluster to the unaided eye. Once the star cluster appear in the sky, the incas mark this as a start of the year, and incas is incas. If you don't know about the Incas, then it is the empire was unique in that it lacked many of the features associated with civilization in the old world, without the use of the wheel, draft animals, knowledge of iron and steel, or even a system of writing. They are advanced, advanced empire at that time. So they mark this as a start of the year if once the Pleiades cluster were appear in the sky, right? Okay, so constellations, you know about the constellations, right? The group of stars. So
Yes, ma'am.
cultures around the world have long performed astronomical observation with the naked eyes, frequently spotting stars, planets, and other celestial phenomena. And these communities often use their knowledge of astronomy for finding navigation, timekeeping, agriculture planning, also the spiritual and religious practices. So, if we know about the Greek mythology, like behind these constellations, like Orion. Orion is a hunter which lies in the sky and stands with having a bow, right? So there are a lot of stories behind these constellations, like you can see in the PPT itself, the background Indus, Aquarius, Capricornus, right? So Orion, if we talk about the Orion, which represented Osiris, the death, rebirth, afterlife. Ancient people have also used these to determine when to plant and harvest crops. So by using the stars, by using the constellation, they decide whether to crop or not, when to harvest crop, right? Also, they use stars to navigate their directions, where to go, when to go. So these are some ancient phenomena during since a long time, thousands of years from now. Okay, if we talk about the Venus, Venus is our planet, right? We called it evening star or morning star also. So have you seen the Venus with your naked eyes?
Yes, ma'am.
Yes, ma'am.
Yes,
Okay,
ma'am.
how many times?
Many times, every day.
Every day, right? Okay, so if we this is the first site of Venus. Okay, the a platform of Mayan for observation Venus. Have you ever heard about the Mayan civilization, Mayan people?
No.
Yes, ma'am.
Mayan people were like the Mesoamericans type peoples, and if, they are like uh, they are civilization, old civilization, right? So they were used uh, the planets to start their things. This planet is considered the third, the brightest sky, and in Mayan culture, the position of Venus was used as a basis in deciding whether to start a battle against another tribe. So once the planet Venus is appear in the sky, they think or they decide whether to start a war or not against the another tribe. So there are a lot of things they do by using the planets and the stars. Even the before even the telescope was ever invented. So these are the things that we know sometimes. How do you think that earth is round? So let's take an example to understand it better. So anyone else, how do you think that earth is round?
Am I audible?
Hello?
Uh,
Yeah.
so I once read a story of I don't know the location, but it was somewhere near the equator, probably in Africa. There was a mathematician who, in the month of January, he took a stick in certain time and he placed it, you know,
Mm-hmm.
dig it in the ground and stick it and saw the shadow at that time, and he went 800 location to another in the next year, in the same month of January he went to 800 kilometers from the same location where the previous year he measured the length of the shadow, and he
Okay, by
uh,
using old instrument
yes,
like Jantar Mantar Observatory.
yes.
Right. Yeah, we also have done this experiment also with the Delhi Planetarium. So these are the observatories, and these are the ancient techniques which we use to determine the calculations, or we used to see the North Pole stars and etc. So these are the old techniques, and later we developed the telescope and many things for that. So how do you think that Earth is round? So if let's watch a ship. Let's take an example first. Let's watch a ship leave its port and sail into the distance on a clear day. On a flat Earth, we would just see the ship get smaller and smaller as it sails away, as you can see in the real time. But this isn't what we actually observe. So this is what instead, ship sink below the horizon with the hull disappearing first and the most remaining visible for a while longer. Eventually, only the top of the mast can be seen as the ship sails around the curvature of the earth. Finally, the ship get disappeared under the horizon. So, many people call it rising or setting down, right? So, as the distance increases, the thing gets smaller, appears smaller and smaller, right? We actually have seen a real life example, ship and another many objects. So instead what happened, it uh, the disappearing and the most remaining visible for a while longer, only the top of the mast can be seen as the ship sails around the curvature of earth. Finally the ship get disappeared under the horizon, means the distance getting longer and longer. So uh, by this means we got to know that the earth is round. And another example is satellite. Aryabhat satellite or many other satellites photograph This photograph is taken from the shuttle, and the other satellites show that the Earth is round from every perspective. Satellites have taken this image of Earth from space, and we got to know about the Earth's shape, that Earth is actually round. Example 3. Suppose you made a friend in each time zone of Earth, right? You call of them as the same hour and ask, where is the sun? On a flat Earth, we caller would give you roughly the same answer. But on a round Earth, we would find that for some friends, the sun would be high in the sky. Some answer sun would be high in the sky, whereas for others, it would be rising or setting down the sun or completely out of sight. But for the ancient, survival skills were a daily necessity. Planting crop at the wrong time or heading in the wrong direction could have disastrous results. Here we compare the example. Here we compare the example of astronomy to day-to-day life before the telescope era. The role of astronomy in day-to-day life. Long before the invention of compass, and people use the stars to find the direction and time, as you can find in this picture, tell time with stars. Did you know that you can tell time at night without a watch or a clock? How many of you have done this before? To tell time with stars without a watch, without a clock. This is a 24-hour clock. This clock you have seen, 1 to 24, this is 24-hour clock, star clock, right? So all you need to do is step out, look up at the sky and locate the Big Dipper and the North Star. Big Dipper is a star constellation. Here in the clock, I have mentioned it, the Big Dipper constellation, this one, and these two stars just below the 24, these two stars, and just below this, the North Pole star. So using the pointer stars at the end of the ball of the Big Dipper, and then just with a little bit of imagination and math, you can do what explorers, adventurers, and astronomers have been doing for centuries: tell time with using stars. So if we go ahead with this clock, then wait a minute. A counterwise star clock. Sorry, my laptop got hanged. Wait a minute. Yeah, right. So just what you need to do, just find a Big Dipper constellation in the sky, and now picture a clock with the North Star as its center, and draw an imaginary line like this. Big Dipper and North Star, we have drawn our imaginary lines, and then starting from the North Star through the two pointer stars of the Big Dipper. Assume that this line is our hand and of your imaginary star clock. The clock you just created in the sky is a 24-hour clock, unlike on a regular analog clock face where an hour takes up 30-degree angle for a full circle. The imaginary hour hand on the star clock moves only 15 degrees per hour. What's more, this hour hand moves counterclockwise. Before you go on to learn how to tell the time, you have to do one last thing. Draw another imaginary line straight up from the North Star. This line will mark midnight or the passing of 24 hours. So that's how you can find the time, and you can tell the time and find the North Star, right? So these are the ancient techniques they used to do since centuries to tell time with the stars. So let's move further. This also using the cleaner triangle of Cassiopeia. Cassiopeia is a constellation. See this in the PPT, and this makes a 90-degree angle. Another technique is you can see using the thinner triangle of Cassiopeia, which is making a 90-degree angle triangle, and the center of Orion's belt through his head shown in the picture. See this, this is north direction, and this is Orion belt, and Orion belt in second picture, and this is heading towards the north. So that's how they also find out the north direction by using the Orion constellation. Using, please mute yourself. Using the summer triangle by starting at Altair and moving through the open end of the triangle closer to Deneb. And this is the summer triangle where you can find where by this we using by this we used to find out the Milky Way. The given picture shows a constellation of Aquila and Cygnus. This here this star called Altair. So using the summer triangle by starting at Altair and moving through the open end of the triangle, closing to Deneb. Deneb is a first picture as a top of this. So by this we also find out the north direction. So telling time with sundials. Sundials is old ancient techniques. So have you used this before, sundial?
No, ma'am.
Okay. Long before the era, people used sundial clocks to measure time. There is a 3,000-year-old technique when astronomers made accurate records of the positions of the stars, the sun, and the moon in the sky. They were starting to understand where these objects would appear at different times. The earliest sundial instrument was a shaped stone marked with shadow length for different times of a day. So this is the oldest clocks in the background of this picture. Sundials are classified into a number of different types, mainly by the plane in which the dial lays: horizontal, vertical, equatorial, polar, etc. Sundials having having latitude and latitude. So I'm thinking you have that you should use sundial for practical knowledge to tell the time, to learn how sundial works. So it will be easy to understand how sundial works. So it is the oldest clock. Well, we knew that the sun's position in the sky can be used to determine the time, but we can do the same using stars, right? Well, yes. So this is a nocturnal. Now, a nocturnal is an instrument which can be used to determine the local time based on the relative position of two or more stars in the night sky. Sometimes called a horologium nocturnal, means time instrument for the night. So this is also this was used in 12th century. The first nocturnal were described in 12th century. So this is a nocturnal. If we buy this, that ancient, we already have a lot of this, so we can use this to tell time. So these are the ancient techniques. We still are using it, like Jantar Mantar Observatory. If you go there, you find out the many old instruments are there to find the North Pole star, to find the Venus. And how do they calculate? They just arrange that thing at that angle that we don't have to do further calculations. They just put it on a 15-degree angle, and how big our shadow is at the winter time and the summer days. So there are a lot of ancient techniques are there. This is a planisphary star chart. It is an instrument to assist in learning how to recognize stars and constellations. The star chart contains the brightest star. constellations, and deep sky object DSOs visible from a particular latitude on Earth. A planisphere is designed for a particular latitude and will be accurate enough for a certain band or either side of that. Planispheres only show the stars visible from the observer's latitude. Stars below the horizon are not included. For some, the stars are setting up or setting down. So the stars below the horizon are not included in this. Only the stars which are already set up in the sky. So this is a old star chart. What did astronomers use before the telescope? Until the development of the telescope in the early 17th century, all astronomical observations were made with naked eyes by using measuring instrument. Astronomers recorded the position of the planet and against the background of stars. So, what did they use before the telescope? As I have already mentioned, they used the techniques to find their directions when the planet visible in the sky. So they conducted as a start of the year when the pleiades occur in the sky. So solar eclipse and lunar eclipse, phases of the moon, motion of stars, visibility of planets, these astronomical phenomena are already known even before the invention of telescope. The phases of moon, the phases of Venus, the Venus planets. As we know, the five planets we can see with the naked eyes. That is all the terrestrial planets and two the Jovian planets. Uh, Mercury, Venus, Mars, Jupiter, and Saturn. These five planets we can see with the naked eyes in our skies. The motion of stars and the constellations and the phases of moon, solar eclipses were already known phenomena before the invention of telescope. So let's discuss the important timeline of the astronomy before telescope. So this is the okay. So we used to believe that the Earth is the center of the universe, which was discarded later on and discovered that the sun is the center of the universe. This is a 1,000-year-old model representing the concept and was later named as heliocentric theory. So heliocentrism is a theory. Helio means sun. So in which the sun is center of our solar system, and other planets are revolve around that. So this is the time before 270 BC and today's 21st century. So how past, yeah, how long before we have known this phenomena? So at the time of 467 BC, this was the first time we got to know that the sun has a huge mass and explain about the rainbows and meteors, and as well as he was the first to explain the moon shine due to reflected light from the sun. Also explain the rainbows and meteors. In 499, Indian mathematician Aryabhatta, he was an Indian mathematician and astronomer, explained that the planets and the moon do not have their own light. And why do we have day and night on Earth? Anybody wanna answer this? The day and night concepts? We can discuss the things in between that. You can unmute yourself and start discussing it.
So, shall I?
Yes, sure.
So when Earth is rotating, so half of its phase when is lit by sun, we call it daytime, and rest, which is in the dark side or the shadow, is the nighttime.
Okay. Anyone else? What is the concept of day and night? No one wanna answer? Okay, okay, before I explain this, take time 1 minute and then answer me. What do you think about the day and night concept?
Ma'am, when half of the Earth's part face to the sun, we will get a day, ma'am.
Sorry. Can you repeat?
Ma'am, half of the part of the Earth faces to the sun, we will get a day, ma'am. And remaining part, due to the darkness, we will get night. Due to the revolution of rotation.
Rotation on its axis.
Yes, ma'am.
Okay. Okay, right. Anyone else wanna explain this? What do you think? You can tell anything. What do you think on it? So he was right. It was day and night are due to the Earth's rotating on its axis, not its orbiting around sun. So, and we know the Earth's orbit the sun. It takes around every 365. It takes around a year, means 365 days, and rotates about its axis in every 24 hours. So day and night are because due to the Earth rotating on its own axis, right? So that was a concept which was explained by the Indian mathematician, Indian astronomer Aryabhatta in in 499, and this is 21st century. See, since how many thousands of years we have known this concept. In 628, the Newton uh, second law of Newton's law of universal gravitation, he gives um, methods for calculations of the motions and places of various planets, their rising and setting, conjunctions, and the calculations of the solar and lunar eclipses. So these are the phenomena were already known before. Nicholas Copernicus was an astronomer and mathematician who gave his theory that Earth travels around the sun. It correctly described the sun as having a central position relative to the Earth and other planets. So he explained in his theory that the Earth travels around the sun. However, he complicates his theory by retaining Plato's perfect circular orbit of the planet. So these are the time of the 1473 to 1543. So that would be my part. Hope the session was informative. How was astronomy in our life before inventing the telescope? How they use the sun and stars to tell the time and find the direction. Astronomy compels the soul to look upward and lead us to world to another. So hope you find this informative. How we use the sky to tell time. Sky means the stars, the planets, the other things. How we use that before the invention of the telescope. So after the telescope came, the world has changed. the world, it is like the beginning the new era after the telescope came. So these were the time before the telescope have ever known, ever invented. So that would be my part. Thank you. Over to you, Charan.
Thank you for the wonderful webinar, Kirti ma'am. I think Charan sir left because of some particular reason. Uh, Hope everybody enjoyed today's webinar and kindly fill the feedback form. And also, who have registered for the certification, don't forget to fill the form. Thank you, ma'am, once again for your valuable time. We have gained a lot of knowledge from this webinar. We have known a lot of new things from this webinar. Hope everybody enjoyed from this webinar and kindly fill the feedback form.
We can start discussing the things. If anyone have a questions and things like that.
Yes, ma'am. If you have any
I had a
queries,
small doubt, ma'am. Hello, ma'am.
Yes.
Ma'am, I thought I had learned that NASA is developing helical engine technology, ma'am. Is it true or false, ma'am?
Helical engine
Engine,
technology.
ma'am.
I didn't receive any news about it. So, to be honest, I haven't read about it yet.
Okay, ma'am, that impulse engine, ma'am.
Yeah, impulse engine. What?
Ma'am, that one of the old
Oh,
guy, ma'am.
wait. We are
He
talking
had
about
developed that.
only this webinar related issues.
Okay, ma'am.
So I would like to ask all of you if someone did astrophotography before. No.
No, ma'am.
Okay. So have you seen Mars, Mercury, and Venus in the sky, or Jupiter, Saturn with your naked eyes?
Yes, ma'am.
Yes, ma'am.
Yes,
Daily,
ma'am.
every day you are seeing.
Yes, ma'am.
Okay. Okay. So try these things like tell time with stars. This technique. This will help you to gain the practical knowledge. Just find out the constellation Big Dipper, and then just below this you can find the North Pole star and draw an imaginary line and start calculating it. So you can know the time, actual time. So by using it you would know about how that time of peoples would do that, right? So there are lots of techniques which we tell the times and other things. So just start doing it. You will definitely enjoying it.
Ma'am, I have a question.
Yes.
Ma'am, North Star won't be visible from southern hemisphere, right?
Sorry.
We can't see North Star from southern hemisphere, right?
Mm-hmm.
So, ma'am, how people who live in southern hemisphere used to navigate in ancient times?
Wait. I didn't get your question.
If North Star is not visible from southern hemisphere, so how did the people manage to, get directions right? You know?
Okay, so I would like you to self-research on that because it would amazing result. It will you will be getting the amazing results, or you will get a lot of knowledge on that about the celestial sphere and northern hemisphere, NSP, SCP. So you will get a lot of knowledge. If I tell you, then there is just this part of story. You will never search yourself about the other part of the story. So just start researching it. Research about it.
Yes, ma'am.
Is Charan there?
No, ma'am, he has left because he has some other meeting.
Okay, okay, fine, fine, fine. So I would like to take a leave as I'm in the office right now.
Thank
So,
you, ma'am. Thank you so much for
Thank
your
you, ma'am.
valuable time.
okay, okay. Thank you.